Hello there, and welcome to the Sleepless Scientist, a quiet corner of the cosmos where your thoughts can unwind, and knowledge becomes a softer lullaby for the night. Tonight, our journey drifts through places in the universe so strange, so visually unreal, that they almost feel like scenes borrowed from dreams or distant paintings. But before we settle in, I would be grateful if you could take a moment to like this video and subscribe, only if these gentle wanderings bring you a sense of calm. And if you feel comfortable, you're welcome to leave a comment sharing where in the world you're listening from and what time it is for you right now. It's always a joy to see how many little lights on the globe quietly gather here for these starlit explorations. Now feel free to dim the lights. Perhaps turn on a soft fan or let the room grow still around you and allow your breathing to settle. Let the world outside fade just a little. Tonight, we drift slowly into the most surreal corners of space. And if your mind begins to wander as we travel, that is perfectly all right. Let it drift. The cosmos will wait patiently. As the quiet draws in, you might imagine the universe as a vast gallery, with each region painted in colours and shapes almost too unusual to believe. Yet every scene we will visit tonight is real. Every cloud, every crater, every river of starlight has been touched by physics older than Earth itself. All you need to do is rest gently and let the images of distant worlds wash over you like soft tides of stardust. When you look up at the night sky, the stars sit so calmly against the darkness that it is easy to forget how wild the cosmos truly is. Our eyes see only steady points of light, but beyond that gentle view lie places sculpted by forces so immense that no part of life on Earth can fully prepare us for them. The universe often appears to be a realm of illusions, vast towers of gas shaped like stone, planets with rain made of molten glass, and stars that swell until their edges blur into space itself. Everything looks as though it belongs in a storybook, yet none of it is imaginary. Every shape is carved by gravity, by heat, by time, and by the quiet rules that govern the sky. Part of the reason the cosmos seems unreal is scale. Our minds evolved to understand hills and rivers, not clouds that stretch for light years, or storms the size of continents. If you imagine holding a grain of sand between your fingertips and lifting it toward the sky, every star you see would fit behind that tiny speck, and still, what you see is only a thin layer of the universe's surface, just the nearest stars in one arm of our galaxy. Everything beyond is hidden behind distance, like layers of mist drifting through a valley at dawn. Light itself behaves differently across these distances. It bends, stretches, and sometimes circles around massive objects, creating gentle arcs known as gravitational lenses. Instead of thinking of them as equations, you can imagine light as a soft ribbon that curves around anything heavy enough to pull at it. Galaxies, with their countless suns, tug on light the way wind bends tall grass. From our point of view, distant objects appear smeared, doubled, or arranged in delicate circles as if someone traced them with a slow, invisible brush. These shapes look like special effect, but they are simply what happens when gravity becomes strong enough to guide the path of light. Another reason the universe appears unreal is the way time behaves across it. On Earth, a day is a day, measured by one turn of our planet. But in the broader cosmos, time stretches and folds. Around massive objects, it slows slightly, the way thick honey moves slower than water. Near the edge of a black hole, a single second can stretch farther than human senses can understand. Nothing dramatic happens in the moment. It is simply that clocks would tick at different rhythms depending on where they rest in the sky. If you picture time as a gentle fabric, stars and planets press into it, creating valleys that slow its flow. It's not a mathematical expression. It's the quiet behaviour of something that usually goes unnoticed. Light itself, also carries the stories of its travels. As it moves through space, it stretches into deeper colours if the object sending it is drifting away from us. Instead of thinking of numbers or symbols, imagine a sound becoming lower as it echoes through a long hallway. That shift in tone mirrors how light changes colour across distance. The universe expands slowly, and as it does, distant galaxies drift farther from us, pulling their light into softer, redder shades. This gentle reddening is one of the reasons many far-off galaxies look ancient, faded, almost watercolour-like. And then there are the shapes, towers of dust rising like mountain ranges, hot gas carved into hollow spheres, clouds glowing in shades of blue and gold. The universe is spacious enough that radiation and stellar winds can sculpt matter into forms that resemble animals, cliffs, storms, or wings. Not because they were meant to resemble anything, but because time and motion leave patterns the way ocean waves leave sand ridges along a beach. Even the pillars of creation, towering 4 or 5 light years high, were not designed to look like columns. They simply became that shape as intense starlight swept through them, pressing and eroding the gas over millions of years. If you were to drift peacefully through these places, you would find the universe is far quieter than it looks in photographs. Nebulae that seem thick enough to touch are actually more delicate than the thinnest mist on Earth. The colours captured by telescopes are often just forms of invisible light translated into shades we can see. The vastness softens everything, making loud events feel muted. A supernova, despite its unimaginable power, would bloom in silence if you watched it from a distance, a bright flower opening in a vacuum. Tonight's journey is not about rushing to understand every detail. It is simply an invitation to sit beside these images, to imagine their slow movements and ancient lights, and to let your thoughts unwind in their presence. As we wander deeper into this cosmic gallery, the illusions will grow stranger and yet more real than any dream. We will begin close to home, with worlds shaped by familiar sunlight and familiar gravity, before drifting outward towards scenes that challenge what our senses expect. When you picture Mars, you might imagine a simple red sphere drifting through the dark, but the closer you draw to it, the more it feels like a world carved with extraordinary patience. Its rusty colour comes from fine grains of iron-rich dust. Dust so light that the smallest breeze lifts it into the air, tinting the entire sky with soft shades of rose and orange. Mars is only about half the size of Earth, yet its landscapes stretch with a sense of vastness that feels far larger than the planet itself. Everything seems exaggerated, as though the planet has been shaped on a different scale, guided by forces that stopped working on Earth long ago. As you drift toward the surface in your imagination, the first thing that stands out is the stillness. Unlike Earth, Mars has no forest to rustle, no oceans to break into waves, no birds to call across empty canyons. The silence sits across the landscape like a blanket, but within that quiet, the planet's history lies exposed. Every ridge, every dune, every scattered rock has been left undisturbed for ages. Mars is a museum of its own past, storing billions of years of wind, ice, and sunlight in plain view. One of the most stunning places on this silent planet is Jezero Crater, a wide basin once shaped by a river that dried out long before humans existed. Today, it holds Belva Crater inside it, a smaller, sharp-edged depression where layers of ancient sediment sit frozen in time. The Perseverance rover captured images of Belva's walls, revealing sheets of stone laid down by flowing water, then hardened, then fractured as the world cooled. When you imagine those layers stacked one after another, it is easy to picture Mars not as a barren world, but as a place where rivers once ran quietly across plains, carving gentle paths toward long-vanished lakes. Nearby, Perseverance has found rock formations that almost look deliberate, their dark surfaces patterned with lines and cracks that resemble the bark of old trees or the dried bed of a once-flowing stream. These shapes are not sculptures, but they feel sculpted. Heat, cold, wind, and time combine to turn this single crater into a gallery of textures. Opportunity, an earlier rover, once parked itself at a place called Greeley Haven, where it spent an entire Martian winter recording panoramic views of red stone stretching to the horizon. The landscape around it looked like a sea that had been frozen mid-wave. Every ripple of soil and every little hill captured in the fading sunlight gave the impression of a world holding its breath. And then there is Valles Marineris, a canyon system so enormous that even calling it a canyon hardly seems accurate. If you placed the Grand Canyon at its edge, it would resemble a faint scratch on the surface. Valles Marineris stretches for a distance roughly 10 times the length of that familiar Earth landmark, and descends 3 times deeper than its greatest depth. If you could stand at its rim, the far side would vanish into the haze. It would feel less like looking across a trench and more like staring into the mouth of a planet. Forming a cut across the Martian equator, the canyon is believed to have opened when the crust of Mars stretched and cracked, possibly from immense volcanic activity or the cooling of the planet's interior. Imagine Earth's crust, but quieter, more brittle, and allowed to settle for billions of years without interruption. Over time, landslides, dust storms, and thin traces of ancient water carved its walls into delicate slopes. The result is a landscape that feels almost impossible. Cliffs taller than mountains on Earth, valleys wide enough to hold entire countries, and plains that look endless. Yet even the grandeur of Valles Marineris is overshadowed by Olympus Mons, a colossal shield volcano that rises like a continent lifted from the planet. Its summit stands about 22 kilometers above the surrounding plains, which is roughly 3 times the height of Mount Everest. Instead of steep slopes, its sides stretch outward gently, as though the mountain is exhaling in every direction. That gentle slope comes from the way lava once flowed thin and wide across the ground, spreading layer upon layer for millions of years. No great eruption built Olympus Mons suddenly. It grew quietly, gradually, like a slow breath of the world beneath it. From its summit, the horizon would appear curved, not because of the planet's roundness, but because the volcano itself is so enormous. Standing there, you would see a world painted entirely in shades of red and soft gold, with dust storms twisting far below like faint ghosts. This is one of those places in the solar system where perspective becomes slippery. You may know the volcano is ancient and cold now, but if you imagine the heat that once pushed it upward, you can almost hear the slow pulse of a planet awakening and cooling again. Mars also hosts 2 small moons, Phobos and Deimos, which circle the planet like quiet companions. They are not round like our moon. Instead, they resemble lumpy stones drifting through the sky. Phobos, the closer one, races around Mars so quickly that it rises and sets twice within a single Martian day, moving in the opposite direction of the stars. Deimos moves more slowly, floating high above the dusk in gentle arcs. Neither moon casts bright light, but both add to the feeling of strangeness. 2 asymmetrical shapes drifting through a pink atmosphere, their shadows gliding silently over the desert. At the poles, Mars keeps another secret: layered caps made of frozen water and frozen carbon dioxide. In the summer, some of the dry ice gently lifts into the air and drifts away like invisible fog. In the winter, it settles back down in thin, delicate layers. Year after year, this cycle continues, as though the planet is breathing shallowly through the cold. These polar layers hold records of past climates, each stripe a quiet note of temperature, wind, and sunlight. If Earth's poles are dynamic and storm-battered, Mars's poles feel timeless, soft staircases of frost under a pale sky. All these places, the craters, the canyons, the volcano, the shifting poles, show that Mars is not just a lifeless rock. It is a place shaped by time in ways that are gentle but vast, still but full of story. Everything on Mars is quieter than Earth. Everything is slower. And in that slow shaping, beauty grows in forms we do not expect. Worlds carved by wind rather than rivers, mountains built from lava that once flowed like syrup across plains, and landscapes so empty that even a single pebble can cast a long, lonely shadow. As we drift onward, the red sands of Mars fade behind us, and the sky ahead begins to brighten with the light of the star that has warmed our world for billions of years. The next step in our journey brings us closer to that golden heart of the solar system. Before we drift farther into the outer reaches of the solar system, it feels right to pause near the warm glow that has watched over Earth since the beginning. The sun is so familiar that it can be easy to overlook its strangeness. You see its light every morning, reflected in quiet puddles or bending softly through curtains. Yet the star itself is a place so powerful and so dynamic that no human sense can fully grasp what happens on its surface. From a gentle distance, it looks like a perfect sphere of gold, steady and reassuring. But if your view could glide closer, not close enough to feel its heat, just near enough to observe, you would see an entire world made of fire, swirling as though the surface were alive. The sun is, at its core, a star in its calm adulthood. Astronomers call this stage the main sequence, but instead of thinking of terminology, imagine a long, peaceful middle chapter in a life story. In this chapter, the sun steadily transforms hydrogen, the simplest kind of matter, into helium. Rather than reciting formulas, picture it as a quiet inner furnace, where tiny particles join hands under immense pressure and release gentle warmth outward. This warmth is what touches your skin on a clear morning. It is what keeps Earth's oceans from freezing. It is what allows seasons, winds, and life to exist. For billions of years, the sun has given this warmth in a nearly constant rhythm, as if it were breathing in and out so slowly that we almost never notice. But beyond that calm exterior, the sun carries an intensity that doesn't show itself at first glance. The surface looks smooth from Earth, but up close it churns constantly. Hot gas rises, cools, and sinks again in patterns that resemble boiling water. Except this is boiling light. These bright cells of motion cover its surface, forming shifting patterns like grains of sand shimmering in bright heat. They rise and fall with a rhythm that spans minutes, hours, and days, creating a kind of heartbeat across the sun's face. Every so often, this giant heart trembles with sudden bursts of energy. A solar flare erupts, an arc of bright fire sweeping outward, lifting high above the surface before it bends back again. These arcs can stretch to distances far larger than Earth itself. One particularly striking eruption, known informally as the Trebuchet event, resembled a stream of glowing plasma being hurled upward before falling gracefully inward, like molten rain retreating under the pull of gravity. There are no equations needed to describe it. You only need to imagine a fountain of light forming in slow motion, each droplet impossibly bright, drifting back to the surface of the star. At times, the sun releases bursts of charged particles so energetic that they slip past the boundaries of the solar atmosphere and travel across the solar system. When these particles touch Earth's magnetic field, They spiral down toward the poles and paint the sky with soft curtains of green, red, or violet. Auroras are not just pretty displays, they are the handwriting of our star, drawn in delicate strokes across the sky. They remind us that Earth is always connected to the Sun, even when entire oceans and thousands of miles stand between us and daylight. Despite these moments of drama, the Sun's greatest gift to Earth is its steadiness. Stars can vary wildly in brightness, but ours glows with a consistency that allows life to flourish. It radiates just enough warmth to keep our oceans liquid, but not so much that our world burns. If the Sun were younger, it would blaze more fiercely. If it were older, it might flicker with instability. Instead, Earth was born during precisely the chapter when the Sun's light is most peaceful. It is a fortunate alignment, the kind that feels almost too gentle to be accidental, though of course it is simply the natural path a star follows as it ages. The size of the Sun also shapes its gentle influence. Though it appears small in the sky, it is large enough to hold around 1 million Earths inside it. That number is immense, but instead of imagining quantities, think of the Sun as a vast lantern with layers upon layers of glowing air. Gravity pulls those layers inward and heat pushes them outward. These two forces, falling and rising, are balanced so precisely that the Sun holds its shape for billions of years. Each moment of equilibrium is like a calm held between breaths. If either force was stronger, the Sun would collapse or burst. But here it is, soft, steady, and enduring. If you could drift just above its surface, not close enough to touch the heat, but close enough to see the play of motion, the Sun would appear almost fluid. Bright swirls twist across its surface. Darker patches known as sunspots sit like shadows on a glowing pond, cooler than the surrounding regions but still far hotter than any flame on Earth. These spots are areas where tangled magnetic fields pierce the surface, slowing the outward flow of heat. Over days and weeks, the spots shift and rearrange as the Sun rotates, slowly on one side, more quickly on the other, like a dancer moving at different speeds across a stage. The star also sings in a way, though not with audible sound. Waves ripple through its body, rising and falling in patterns that astronomers can record and translate. It is a subtle music, more like the trembling of a plucked string than a melody, but it reveals the inner layers of the Sun much like an echo can reveal the shape of a canyon. Every part of the Sun is in motion, yet that motion is so vast and calm from a distance that it all blends into a steady glow. Just the sunrise, the warmth on your face, the soft gold that fills a quiet room in late afternoon. The Sun may be a world of fire, but to us it is the most familiar companion in the sky, and that familiarity has shaped how life sees the universe, by its light, by its warmth, and by the gentle rhythm of day and night. As we begin drifting outward once more, leaving behind the glowing surface of our star, the solar wind softens and the darkness opens ahead. Larger worlds are waiting, the giants of swirling storms and luminous rings that stand like cosmic monuments in the cold. As we drift outward from the warm glow of the Sun, the light begins to soften. Shadows stretch farther. The familiar brightness of the inner solar system slowly fades behind us, and in its place rises a vast, cool expanse. Here, 4 enormous worlds circle the Sun, planets so large and so dramatically different from Earth that they feel almost like mythological beings rather than places shaped by natural forces. Their colours, their storms, their rings and their magnetic fields seem exaggerated, as though painted by a restless cosmic artist. Yet each one exists, steady and real, turning in the cold. Jupiter is the first of these giants. It is so large that more than 1,000 Earths could fit inside it, though instead of imagining measurements, it may feel simpler to picture Jupiter as a miniature solar system of its own. Its swirling atmosphere is a tapestry of browns, creams, reds and golds, all arranged in long bands that wrap around the planet like ribbons pulled tight. These bands are powerful jet streams that race in opposite directions, creating boundaries where storms form, storms that can last centuries. The most famous of them is the Great Red Spot, an enormous oval swirling with winds faster than any hurricane on Earth. If you hovered above it, you would see a maelstrom the size of our entire planet, yet moving with a strange grace. Its edges curl inward like the folds of a vast, slow-turning whirlpool. No human ear could ever hear it, but the patterns of its motion create a rhythm all their own. Although the storm has been shrinking over the past few decades, it still remains one of the most majestic and persistent features in the solar system. The dance between Jupiter and its moons adds to the sense of grandeur. 92 of them have been confirmed, each moving along its own silent path. Io, the closest large moon, is a world of volcanic fire. Its surface is dotted with geysers that send plumes of sulfur high into the space around it. Some eruptions burst so powerfully that they rise hundreds of kilometers before falling back like glowing sparks. One such eruption, at a place called Tvashtar, was captured by a passing spacecraft, its fountain of molten rock stretching into darkness like a frozen flame. Just beyond Io lies Europa, quieter on the surface but hiding something extraordinary beneath. Its shell of ice is streaked with dark lines, fractures caused by tidal forces from Jupiter's immense pull. Under this icy surface rests a deep ocean of liquid water warmed by the moon's interior. It is in darkness, unseen by any eye, but it may be one of the most promising places in the solar system for life. From above, Europa looks like a smooth marble crossed with delicate filaments, but inside it carries an ocean that could be larger than all the oceans on Earth combined. Farther out still is Ganymede, the only moon with its own magnetic field. Imagine a world large enough to rival the planet Mercury, but covered in ice and shadow. Beneath that ice lies another hidden ocean. In this corner of the solar system, water is not a rare treasure, but a quiet presence, waiting beneath frozen surfaces. Jupiter itself glows with more than just reflected sunlight. At its poles, auroras shimmer in patterns brighter and more energetic than anything seen on Earth. These lights are stirred by charged particles from the Sun, as well as particles released from Io's eruptions. If you could drift above Jupiter's poles, you would see luminous rings and spirals moving across the darkness, like cosmic brushstrokes drawn in electric blue. Leaving Jupiter behind, we move towards Saturn. Where Jupiter is massive and turbulent, Saturn feels delicate, almost serene. Its rings, stretching outward in thin luminous layers, give it a sense of elegance that few other worlds possess. These rings are made of countless pieces of ice and rock, from tiny grains to fragments the size of small houses. Sunlight catches on them, creating a glow that feels almost too fragile for a world so large. When viewed from above, the rings appear like the fine edge of a porcelain dish, almost weightless. Saturn's moons also contribute to its enchantment. Titan, its largest moon, holds a thick orange atmosphere richer than anything else in the outer system. Rivers of liquid methane cut across its surface, emptying into dark, still seas. Its landscapes of dunes, lakes and river deltas give it an eerie familiarity, as though someone took Earth's coastlines and painted them with colder colours under a dimmer sky. Then there is Enceladus, a tiny moon of ice that should have been quiet but isn't. Along its south pole, long fractures called tiger stripes crack the surface. From these cracks, plumes of water vapour and fine ice shoot upward into space. These geysers drift outward like pale smoke and fall back as soft snow. Beneath the ice lies an ocean warmed from below. Even in a place so far from the sun, liquid water finds a way to exist, whispering its presence through these sprays of frozen mist. Uranus, the next giant, is stranger still. It rotates on its side as though some long-ago event gently tipped it into a sideways slumber. Because of this, each pole experiences 42 years of unbroken sunlight, followed by 42 years of darkness. Under such conditions, seasons become stretches of time longer than a human childhood. Its pale blue-green colour comes from methane gas, which absorbs red light and reflects cooler hues back into space. Rings, narrower and darker than Saturn's, circle the planet like faint strokes of charcoal. Its moons carry their own oddities. Miranda, one of the smaller ones, has cliffs so tall that if you fell from their highest points, you would drift for 10 minutes before touching the ground, the low gravity slowing everything into a quiet descent. Neptune, the farthest giant, is a deeper, richer blue. Its colour comes from methane as well, but there seems to be another element at play, something that enhances the hue into a deeper shade. Winds on Neptune roar faster than any wind elsewhere in the solar system, yet from afar the planet looks calm, almost uniform. Its rings are thin and faint, barely visible, while its largest moon, Triton, orbits backward, opposite the direction of Neptune's rotation. That unusual movement hints that Triton was once a wandering body, captured by Neptune long ago. Today it hosts geysers of nitrogen that burst quietly into its thin atmosphere, leaving dark trails along the surface. These four giants, each of them vast, cold and powerful, remind us that planets can take on forms entirely unlike our own world. Jupiter is a storm-filled titan, Saturn a world of delicate rings, Uranus a tilted sphere of calm, and Neptune a deep blue wanderer at the edge of sunlight. Together, they form a kind of celestial procession, each one carrying a different expression of what a planet can be. And as we continue drifting outward, leaving their swirling atmospheres behind, the solar system begins to thin, and the smaller, quieter worlds await with their own subtle wonders. As we leave the great planets behind, the solar system grows quieter. The space between worlds widens, and the sunlight fades into a softer, cooler gold. Out here, the places we meet are smaller, colder, and often overlooked. Tiny worlds that drift at the edges of warmth, yet in their silence, they hold some of the most haunting and beautiful landscapes in the solar system. Unlike the giants with their swirling storms and luminous rings, these worlds speak in quieter tones. Their surfaces preserve ancient stories, written not in roaring winds, but in frost, shadow, and stone. The first of these quiet worlds is Mercury, the closest planet to the Sun. Despite that nearness, Mercury is not a blazing inferno in every moment. Instead, it suffers through extremes that no Earth landscape could withstand. On its sunlit side, temperatures rise high enough to melt metal, but because it has almost no atmosphere to hold heat, the night side plunges into bitter cold, reaching depths far below freezing. It is a world of contrasts, as though stitched together from fire and ice. Though we could describe its temperature swings in numbers, it is gentler to imagine standing on the surface at dawn, feeling the cold ground still clinging to the night while sunlight begins to pour over mountains and ancient craters like a slow tide. Among its most impressive features is the Calorus Basin, an impact crater so broad that it would cover an entire continent on Earth. If you stood at its centre, the curved rim would rise in the distance like a ring of mountains. The impact that formed it was unimaginably powerful, shaking the entire planet and rearranging the crust on the opposite side. Over billions of years, Mercury has carried that scar quietly. like the memory of a great event it never forgot. From the scorched landscapes of Mercury, the solar system stretches outward toward colder realms. Eventually, far beyond the orbit of Neptune, we reach Pluto, a world once called a planet, then a dwarf planet, but always a place with a personality entirely its own. When NASA's New Horizons spacecraft swept past in 2015, Pluto revealed details no one expected. Mountains of solid ice rising 3.5 kilometers into the sky, valleys carved from frozen nitrogen, and vast plains shaped into strange polygon patterns by slow, creeping flows of glaciers made not from water, but from mixtures of nitrogen, carbon monoxide, and methane. Pluto's colours are one of its greatest surprises. Though icy, it carries a faint reddish tint in many regions, created by complex organic compounds called tholins. These tholins form when sunlight interacts with the methane in Pluto's thin atmosphere, generating tiny particles that settle onto the surface. The result is a world that looks like a painting in deep reds and whites. The contrast between its icy heart-shaped plane and its dark reddish regions gives Pluto a sense of personality, as though it were a world with its own quiet moods. Orbiting alongside Pluto are 5 small moons, the most curious of which is Styx. Many astronomers believe it was born from a collision long ago, when 2 large bodies struck and sprayed fragments into space. Over time, these fragments gathered into moons. Styx is one of these relics, small, irregular, barely held together by its own gravity, and drifting like a forgotten shard of ancient chaos. Closer to home than Pluto, yet still part of this frozen family, lies the Moon, Earth's companion for billions of years. Though its face is familiar, the Moon is an oddity in the solar system. It is unusually large compared to the planet it orbits, a quarter the width of Earth. Most moons elsewhere are tiny in comparison to their planets, but ours is a giant relative to its parent. This unusual size has shaped Earth's entire history. It steadies our planet's tilt, keeping our seasons gentle and predictable. Without the moon's steadying pull, Earth's axis would wobble dramatically, shifting climates and making long-term life far more difficult. The moon's seas, which cover about 1/6 of its surface, are not seas at all but plains of hardened lava, dark, smooth regions formed billions of years ago when molten rock welled up from the interior. Sailors once imagined these plains were filled with water, naming them with words like tranquility and serenity. One of these plains became the landing site of Apollo 11, where 2 humans stepped onto the surface for the first time, leaving footprints that will remain there for millions of years unless something strikes the moon hard enough to erase them. Not far from the orbit of the moon lies the asteroid belt, and within it rests Ceres, the largest object in that region and one of the few dwarf planets close enough for detailed study. Ceres is a world of contrasts, a mix of rock and ice that hints at a complex past. Unlike many asteroids, Ceres shows signs of internal activity. Its surface contains bright patches like scattered jewels, the most famous of which shimmer inside a crater. These bright spots puzzled astronomers until a closer look revealed they were salt deposits left behind by briny water that once seeped up from underground and then evaporated. It is a quiet reminder that even small worlds can hold oceans of possibility beneath their surfaces. Another remarkable feature of Ceres is Ahuna Mons, a solitary mountain that rises sharply from the surrounding plains. Its slopes look smooth, almost polished, suggesting it is younger than much of the surface. Scientists believe Ahuna Mons may be a cryovolcano, a volcano that erupts cold materials like water, ammonia, or brine instead of molten rock. Instead of lava glowing red, imagine icy slurry pushed upward, freezing instantly into sharp ridges and clean lines. It is a volcano built not from fire, but from cold. Beyond Ceres lies an enormous ring of icy bodies called the Kuiper Belt. This region is like the attic of the solar system, filled with ancient objects preserved in the cold, untouched for billions of years. Here we find dwarf planets like Haumea, with its elongated shape and a ring circling its equator, Makemake, bright and distant, and Eris, heavier than Pluto and coated with a thin layer of frozen methane. Among the most unusual residents is Arakoth, an object shaped like two spheres gently pressed together. It was visited by New Horizons after Pluto, revealing smooth contours and faint colour variations. The shape suggests a slow, gentle merging long ago, when two bodies drifted together in the calm darkness. Instead of colliding violently, they simply touched and stayed, like two snowflakes settling against one another. These small, frozen worlds, Mercury with its scars, Pluto with its icy mountains, Ceres with its hidden ocean, the Moon with its steady companionship, and the distant residents of the Kuiper Belt, remind us that size is no measure of wonder. Though they are quiet and often overlooked, each carries its own story written in ice and stone, and as we leave them behind, turning our gaze toward the stars beyond the solar system, the universe opens wider, inviting us to explore worlds stranger than anything we have imagined. As we drift beyond the familiar borders of our solar system, the sunlight fades into a gentle memory. The stars around us no longer belong to our own celestial neighbourhood. They sit in patterns we do not recognize, cooler, dimmer, or older than the sun. Somewhere among these distant lights lies an intriguing world known as Kepler 452b. Though we cannot visit it, and though no human eye has seen its surface, the clues we do have paint a landscape so atmospheric and otherworldly that imagining it feels like stepping into a dream. Kepler 452b orbits a star much like our own sun, though slightly older and a little brighter. If you imagine holding a lantern whose flame has been burning just a bit longer than ours, that would be the way this star warms its planets. Kepler 452b circles this lantern at a distance so similar to Earth's that astronomers once called it Earth's cousin. Instead of focusing on labels, it may be easier to picture this world as an alternate version of our own, an Earth written in deeper colours, shaped by slightly stronger gravity and softer light. This planet is larger than Earth, with a mass estimated to be several times greater. Rather than thinking of numbers or symbols, imagine walking on a surface where each step feels just a little heavier, as though your boots were dipped in gentle clay. Mountains might rise more slowly over distance, their slopes wider and sturdier. Trees, if they exist, might grow with thicker trunks and deeper roots to withstand the constant downward pull. Every movement would feel grounded, tethered softly to the soil. Kepler 452b would be a world where gravity whispers rather than shouts, but its whisper would be unmistakable. Because its star is older, the light reaching the planet may appear more golden, tinged with faint reds. Imagine sunrises that last longer, stretching across valleys in soft gradients of amber and vermilion. Clouds filled with volcanic dust or tiny mineral particles could scatter this light into dusky curtains of colour, giving the air a warm, hazy glow. This haze might wrap the entire landscape in a soft veil, diffusing brightness into a gentle blush. Under such conditions, the surface of Kepler 452b could be shaped by intense geological activity. Larger planets often hold their internal heat for longer periods, so volcanoes may remain active for eons. Instead of roaring eruptions, imagine slow rivers of lava flowing like glowing syrup down ancient slopes, cooling into twisted rock formations that resemble frozen waves. The air near these regions might shimmer with heat, forming mirages that drift like faint spirits above the ground. If life exists there, it would adapt to these unusual rhythms. Life does not require Earth's exact conditions to form beautiful patterns. It simply takes the materials it has and grows into whatever shapes fit the world. When imagining Kepler 452b, it helps to picture an ecosystem sculpted by dimmer light and heavier gravity. Perhaps forests grow inward rather than upward, their canopies low and dense. Perhaps leaves glow faintly as they absorb every scrap of sunlight in the misty air. On this imagined world, towering organisms may rise like softly glowing spires. These hypothetical beings, call them lumiveracs in a poetic sense, might have thick trunks to support their height and translucent surfaces that capture the faintest glow. Instead of leaves, they may have branching filaments that drift gently in the breeze, lighting up like embers when touched by sunlight. Their roots would wind deep underground, pulling minerals from soils enriched by constant volcanic renewal. Along cliffs or near sources of warmth, delicate vines, nectamista, as we might imagine them, could float lightly, anchored only by thin tendrils. These airy plants might absorb moisture directly from the humid atmosphere, capturing nutrients through tiny rootlets that hang like lace. They would sway silently, responding to shifts in the air the way seaweed responds to the pull of tides. Where plant-like life exists, animal-like creatures might follow. Imagine gentle herbivores shaped by heavier gravity, bodies low to the ground, supported by wide limbs. Their skin could be coated in glowing lichen, a symbiotic partner helping them blend into forests lit by bioluminescent hues. These imagined creatures, perhaps called Ruminator obscurus, might move quietly through the undergrowth, consuming thick, mineral-rich vegetation with slow patience. In volcanic regions, life might take on more daring forms. Picture a species adapted not only to heat, but to actual molten rock. These beings, ignivorous in a poetic description, could resemble long, serpentine shapes glowing from within, with bodies resistant to the intense warmth. They might move slowly, disappearing into cracks where magma flows beneath the ground, their glow fading like coals cooling in the dark. Not all imagined life on Kepler 452b would be tall or luminous. Some may stay close to the ground, relying on senses unfamiliar to us. In the damp, misty air, hearing might travel through the soil better than through the air. Picture a creature like Umbraque auris, whose oversized ears touch the ground lightly, reading vibrations the way a reader traces words in a book. Fog would not hinder such an animal. Instead, it would become a shield, helping it blend into dim surroundings. Even if no life exists there, and we must always hold that possibility gently, Kepler 452b would still be a world of extraordinary poetry. Its valleys would stretch under hazy skies, its mountains would carry the scars of ancient fire, and its plains would glow with the colours of minerals warmed by golden light. Storms might roll across the horizon in slow, deliberate waves, sculpting dunes and shifting rivers of sand. The atmosphere could trap heat in deep layers, creating thick clouds that move in wide, sweeping patterns. Water, if present, might carve channels into the rock, leaving behind terraces and deltas shaped by centuries of gentle flow. If rain falls, it could be tinted by fine volcanic dust, drifting from the sky like reddish drapery. And at night, when the star dips below the horizon, the world might glow faintly with the heat of its own interior, its rocks warm enough to radiate a subtle shimmer. Kepler 452b is a reminder that Earth is not the only mould for beauty. The universe allows worlds to become strange gardens, sculpted by different lights, different gravities, and different histories. Even without travelling there, Imagining its landscapes teaches us that life, whether real or hypothetical, adapts not to perfection but to possibility. And so, as we slowly drift away from this red-hazed cousin of Earth, the starlight thickens again. Ahead lies another world, one where day and night never trade places, where one side burns under eternal sunlight while the other sleeps in everlasting dark. It is toward that tidally locked sphere that we now quietly wander. As we drift farther into the quiet reaches of interstellar space, the sunlight of home fades into a memory. Stars become smaller and cooler around us, their light gentler, more subdued. In this softer darkness, we arrive at a world unlike any we have seen so far, a place where the concepts of morning and evening do not exist, where shadows never wander, and where half the planet bathes in unending daylight, while the other half sleeps in perpetual night. This is Gliese 667 cc, a rocky world orbiting a faint red dwarf star about 24 light-years away. Red dwarfs are small, cool stars that burn with a steady, muted glow. Instead of the bright golden light of our sun, their radiance is closer to the warm ember of a fire burning low in the hearth. If you could stand on Gliese 667 cc's dayside and look upward, the sky might feel dim compared to Earth at noon, more like the soft light of dusk stretched across an entire lifetime. The star would not blaze overhead. It would simply hang in the sky like a deep red lantern, its glow gentle but constant. Because the planet orbits its star closely, it is likely tidally locked. Tidal locking is easier to imagine than to describe in technical terms. Picture a dancer who always faces the same direction no matter how she turns around a partner. The orbit continues, the motion never stops, but her face never turns away. For Gliese 667 cc, this means one hemisphere is locked forever toward the star, while the other never sees a single ray of sunlight. This creates a world divided not by continents or oceans, but by light itself. On the day side, landscapes might stretch beneath an eternal reddish glow, while on the night side the darkness may feel boundless and absolute, illuminated only by distant stars or perhaps the faint shimmer of volcanic plumes. Between these extremes lies a thin, dim ring of twilight, called the Terminator Zone, where day and night meet in a permanent balance. If ever life evolved on such a world, this gentle band might be its sanctuary. The dayside would feel warm, possibly even hot, depending on the thickness of the atmosphere. If clouds gathered, they might drift slowly in the steady light, forming broad, reddish layers that hang above silent plains. Instead of rushing weather systems like those on Earth, the atmosphere might circulate more simply, warm air rising at the substellar point, the location directly beneath the star, and spreading outward before cooling and sinking on the night side. The rhythm would be slower, more predictable, like the steady draw and release of breath. In the heat of perpetual daylight, imagined plant-like organisms could grow low to the ground, their shapes adapted to conserve moisture and shield themselves from constant warmth. Instead of leaves, they might have thick, mineral-rich plates for absorbing the star's dim red rays. These beings, call them luminar trees, might glow faintly along their trunks, drawing energy not only from the sky but also from nutrient-rich soils fed by volcanic minerals. Their glow would not be for beauty but for communication, a soft pulse that signals to others in the perpetual daylight. Where the land becomes uneven, the atmosphere might shimmer above jagged rocks. In these areas, another imagined form of life might thrive. Creatures lifted by pockets of warm air. Stratovids, delicate beings with elongated limbs and air sacs beneath their bodies, could momentarily float above the terrain, using small gusts of rising heat to cross obstacles. Their legs might hang beneath them like strands of cloth, swaying gently with every drift. Farther from the star, the twilight zone might support an entirely different collection of life. Here, warmth and cold meet, forming gentle breezes that carry moisture. Thin mists might wrap the landscape, forming halos around rocks and plants. In this dim band of eternal evening, bioluminescent organisms could thrive. Plants or fungi with luminous veins tracing delicate patterns along the ground. They might serve as gentle beacons for nocturnal creatures. Among these would be luminopods, imagined four-legged animals with large reflective eyes. Their skin might be covered in dark, velvet-like patterns that absorb warmth during the day and release it slowly at night. Their legs could glow faintly at the joints, tiny bioluminescent spots used for navigation in fog. As they move, those spots would flicker softly, creating the illusion of drifting fireflies along the ground. Deeper into the twilight, you might encounter spirolumbras, imagined creatures that carry long, spiral-shaped tails capable of sensing shifts in radiation or magnetic fields. They might coil these tails to warn one another when a solar flare alters the atmosphere, their bodies humming with faint vibrations pass through the ground. The night side is where the world becomes truly strange. Here, the cold may be extreme, and the sky so still that sound barely carries. Ice might form in crystalline sheets across wide plains. Tall, spindly structures, either mineral towers or life forms adapted to the dark, could rise in seemingly fragile shapes. In this frozen silence, some creatures could have adapted to survive by extracting moisture from the air itself. Hydratophages, imagined beings with wide, flat tongues and scales that reflect the faintest starlight, might glide across icy fields. They could drink from the air the way some desert animals on Earth drink from dew, storing every drop within their bodies. In volcanic regions, the ice might split open to reveal glowing cracks where heat escapes from deeper layers. In these warm pockets, another kind of life might grow. Florotherms, plant-like beings with luminous blooms sprouting from their fur-like coats. They might attract insect-like organisms with gentle pulses of light, using warmth to generate colour even in total darkness. The contrast between the day side and night side is so stark that the boundary region, the terminator zone, may be the only place where temperatures are mild enough to support flowing water or stable atmospheres. In this narrow band, rivers might move quietly, fed by melting ice or geothermal springs. Mists could drift across low valleys in a permanent twilight, never burning away or fully freezing. If winds travel from the warm side to the cold side, they would carry scents, spores, and perhaps seeds, creating a slow and delicate exchange of life between the two worlds. Even without life, Gliese 667cc would still be mesmerizing. Its landscapes would be a study in contrasts. Warm deserts of red stone, glittering ice plains beneath starlight, and a ring of twilight where colours blur softly. Its skies would reveal the quiet glow of a red dwarf star, sometimes brightened by flares that briefly intensify the light before fading again. The idea of walking through a world where day never ends on one side and night never ends on the other is both unsettling and soothing. In a way, Gliese 667cc represents two worlds held together by a thin thread of dusk. This delicate balance, shaped by the simple geometry of orbit and rotation, reminds us that strangeness in the universe often arises from ordinary rules followed under extraordinary conditions. And now, as we drift away from this world split between light and dark, the stars shift once more. Ahead lies another distant cousin of Earth, a place where oceans and continents may hide beneath clouds, where gravity feels familiar yet subtly altered, and where life, if it exists, could bloom in unexpected colours. our quiet journey moves onward toward that imagined Earth-like world. As our quiet journey moves deeper into the starfields, we drift toward a world that feels strangely familiar and yet dreamlike in ways Earth has never been. This place is known by the gentle code name KOI 4878001, a potential Earth-like world orbiting a distant star more than 1,000 light-years away. The name itself sounds cold and technical, but names can be misleading. Behind that string of letters and numbers may lie a planet with oceans, storms, mountains and seasons as soft and varied as those we know. There is a possibility, still unconfirmed, still wrapped in mystery, that KOI 47801 could be one of the most Earth-like worlds ever detected. Instead of thinking of its catalogue label, imagine approaching this world as you would approach a faint but promising memory, something familiar in shape but touched with colours you've never seen before. The planet is believed to orbit its star at a comfortable distance, receiving a level of warmth that could allow water to remain liquid. Its year may stretch a little longer than ours, close to 1¼ Earth years, giving its seasons a slightly slower rhythm. If Earth changes its face 4 times a year, KOI 48701 might do the same, but in leisurely steps, as though savouring each transformation. Because the planet is thought to be slightly larger than Earth, its gravity may feel firmer underfoot. Instead of imagining complex measurements, picture standing on a wide plain where your steps feel more anchored, as though the ground holds you lovingly in place. This firmer pull would shape everything that lives there. Mountains might not rise as sharply. Instead, they would stretch outward in long, gentle slopes. Rivers would carve deeper channels, their currents flowing with stronger determination. Trees, even if they evolve from entirely different chemistry, would grow closer to the ground with thicker branches, their roots spreading like braided ropes beneath the soil. The atmosphere of KOI 4878101, if it exists as astronomers suspect, could be rich with gases that trap just enough warmth to keep oceans from freezing. Instead of giving numbers for pressure or composition, imagine inhaling air slightly denser than Earth's, carrying the faint sweetness of minerals warmed by sunlight. Clouds might form in layered sheets, creating skies streaked with shimmering silver or pale gold. During sunrise, the light could scatter through these layers in soft ribbons, painting the entire horizon with glowing amber tones. The continents on this world might stretch in long, sweeping shapes, where tectonic plates shift unhurriedly across the surface. Volcanoes could emerge regularly, not in violent bursts, but in slow, persistent flows that reshape valleys over centuries. The rocks around these volcanic plains might shimmer with a metallic luster, reflecting sunlight in warm sparks. These minerals, formed under stronger gravity and different atmospheric chemistry, could give the ground a subtle sheen, as though dusted with crushed gemstones. If water flows across KOI 4878101, it may gather into oceans that glisten in deeper shades than ours. Perhaps they are tinted turquoise mixed with touches of green or copper, depending on the dissolved elements carried down from mountains. Waves might move slightly differently, their crests pulled tightly by stronger gravity. They would rise not as high, but break with a more deliberate rhythm, like steady breathing. Along the shores, winds might carry scents of lush vegetation or volcanic steam, blending into an aroma entirely unlike anything on Earth. If the planet hosts life, its biosphere would be shaped by these subtle differences: gravity, atmosphere, and light. Imagine low, radiant plants blanketing the ground in sweeping meadows. Flamifolia, as we might call them, could have spiral leaves that shimmer with golden highlights, curling tightly to store warmth during cool nights. When the wind passes across them, the entire field might ripple with light, as though sunlight were playing across tiny mirrors. Among these glowing plains, herbivore-like creatures Terraclepus could graze, their bodies covered in segmented shells that scatter brightness like polished stone. Their shells might serve as protection from predators or as a way to reflect excess heat. When these creatures gather in herds, their combined reflections could form waves of flickering colour stretching across valleys. In deeper forests, shadow-dwelling animals might evolve darker forms, using camouflage to remain unseen. Obscura vox, imagined as predators shaped like living silhouettes, could melt into the darkness between trees. Their bodies might absorb more light than they reflect, leaving only faint outlines behind. When they move, the air might shift softly, like a curtain brushing against a doorway. Perhaps its mountain regions, Cresta Solaris, herd animals with glowing crests along their backs, communicate through pulses of light. These crests could flicker in patterns, slow waves for calm, sharp flashes for warning, and soft halos for gathering the young. In the thin air of mountain twilight, such displays would be breathtaking. Small beacons gliding along the slopes like moving constellations. Near volcanic regions, the world may host hardy, heat-loving creatures. Infernopolids, imagined beings with ceramic-like armour on their legs, could wander along the edges of steaming fissures. Their bodies might endure temperatures close to boiling, allowing them to drink from hot springs that would be dangerous for any earth creature. Their legs, hardened by minerals from the volcanic ground, could clink gently with each step, producing soft notes like tapping stone. And perhaps among all these imagined forms there would be Plumiferax, small warm-blooded animals with luminous tail feathers. These feathers might glow more brightly as the creatures warm themselves or communicate with one another. During mating seasons, entire forests could sparkle with drifting lights as Plumiferax leap between branches, leaving faint trails of radiance behind them. Viewed from a hilltop, Bestemd, it might resemble a sky full of fireflies that have chosen to live closer to the ground. Even if none of these lifeforms exist, Quai 4878 Dor remains an intriguing possibility. A world that offers a canvas for our curiosity. Its continents might be carved by winds slower or stronger than ours, its skies layered with unfamiliar colours, its lakes filled with minerals that stain the water in gentle shades. Storms could roll across its plains in great arcs, their clouds shaped by heavier gravity into long sweeping forms. When night falls on this world, the sky could shimmer with unfamiliar constellations, patterns of stars that no human eye has traced into stories. If the atmosphere is lush with moisture, halos might form around the planet's star during twilight hours, casting soft rings of light that fade into darker hues. And if moons orbit KOI 4878K.01, they might rise slowly behind cloud banks, glowing with faint colours shaped by their soils and ices. Every imagined detail invites us to think about the nature of home. What makes Earth feel familiar? What would it feel like to stand on another Earth, shaped by different physics yet bathed in the same calm possibility? KOI 4878-1 is more than a candidate for habitability. It is a reminder that Earth is one expression of what a life-friendly world can look like. The universe may hold countless others, no less real, no less beautiful, no less extraordinary. As we drift away from this imagined sister of Earth, the starlight ahead grows stranger again. Soon we will wander into realms that challenge not only our imagination but our understanding. Worlds of molten rock, sideways storms, and darkness so complete that even the definition of planet begins to blur. And so, gently, our journey continues. As we drift away from the softly familiar possibilities of Earth-like worlds, the stars ahead begin to take on a different tone, colder, stranger, and filled with places where the usual rules of planets seem to unravel. These are worlds sculpted not for comfort, but for spectacle. They remind us that nature is endlessly creative, that physics can be both fierce and elegant, and that the universe holds landscapes no dream could ever fully imagine. The worlds we're about to visit are real, or at least strongly suspected to be real, yet they look like illusions painted across the canvas of space. One of the most astonishing among them is a planet with a ring system so vast that if it replaced Saturn in our own skies, its rings would stretch wider than the full moon by hundreds of times. This is J147b, sometimes poetically called a super Saturn. Instead of giving numbers or symbols, picture a world orbited by billions of icy fragments, arranged in a structure so large that it would fill a fifth of the night sky if seen from Earth. These rings might shimmer like silver dunes, each grain of ice reflecting the distant light of its star. The shadows cast by the rings could fall across the planet's clouds in colossal arcs, creating shifting lines of dusk and dawn as the world rotates below. Far more hostile is WASP-12b, a world so close to its star that its dayside becomes unimaginably hot enough to turn metals into glowing liquids. But instead of thinking of harsh figures, imagine a world that has been pulled close to a bonfire, forced into a dance so tight that gravity begins to reshape it. WASP-12b stretches into a subtle oval, slightly elongated in the direction of the star, as though drawn by invisible hands. It is also incredibly dark, absorbing almost all the light that touches it. Looking at it from afar would feel like staring into a piece of charcoal suspended against a glowing background. Even its atmosphere is being slowly pulled away, drifting into space like wisps of smoke from a dying ember. Not far behind in strangeness is Trieste-2b, a world even darker than WASP-12b. It reflects almost none of the light that reaches it, less than polished black glass, less than coal, less than the stillness of a moonless lake. If a traveller could look upon it, they might see only the faintest red glow of heat rising from its atmosphere, a dim ember marking the place where the planet turns around its star. Imagine holding a stone heated in a fire until it barely glows. That is how Trieste-2b would appear, drifting silently in orbit, nearly invisible against the dark. Then there is HD 18973b, a world painted in vivid blue, though not for reasons familiar to Earth. Its colour does not come from oceans or atmosphere like our own, but from tiny particles of glass suspended in its air, glass formed from silicate minerals lifted by fierce winds. On this planet, storms rage with speeds faster than 1,000 miles per hour. Under such winds, the glass particles become shards carried sideways, cutting across the atmosphere in sheets of shimmering rain. Instead of falling gently, the rain sweeps horizontally, striking anything in its path like a storm of glittering needles. To imagine standing in such a storm is impossible. Even picturing it from afar feels like a vision from myth. Another world, K2-141b, carries heat to an even more dramatic extreme. One hemisphere faces its star forever, just as Gliese 667cc remains locked in light and darkness. But K2-141b's star is much closer, and its dayside becomes a blazing furnace. Rocks do not merely warm, they evaporate. The stone beneath the surface turns into vapour, rises, cools in the upper atmosphere, and then falls back to the ground as rain made of condensed rock. It is a stone cycle, a rocky echo of Earth's familiar water cycle. Lava oceans may stretch across the dayside, glowing with molten brightness, while winds carry vaporized minerals high into the sky before they condense and return as rocky frost. It is a world where the landscape is caught in an endless loop of melting and hardening, shaping mountains and plains in slow molten pulses. While these fiery planets seem far removed from anything resembling life or comfort, some worlds exist in a realm of quiet darkness, untouched by the warmth of any star. One of these wanderers is OTS-44, a rogue planet that drifts alone through space without orbiting a sun. Instead of circling a star, it moves through the galaxy like a silent traveller, wrapped in its own faint heat left over from formation. Without starlight, its skies would be black except for the distant pinpricks of neighbouring stars. Yet it is not entirely cold. Deep inside, warmth lingers, enough to keep gases swirling around it in a thin, ghost-like atmosphere. Some scientists believe it may even hold a disk of gas and dust, strange to imagine for a planet wandering the dark without a companion star. But gravity is gravity, no matter where it roams, and OTS-44 holds its small universe together as it drifts through endless night. The strangest worlds of all orbit dead stars, pulsars, whose beams of energy sweep through space like cosmic lighthouses. One such planet is called Grandeur, the innermost survivor in a system blasted by the death of its star. Its orbit is so close and so fast that it completes a year in less than 9 hours. To describe that in simpler terms, a sunrise, a noon, a sunset, and a return to midnight could all happen between morning coffee and lunchtime on Earth. Around a pulsar, the concept of a day becomes peculiar. Light does not arrive from a warm star, but from the sharp, rhythmic flash of beams that spin across the sky, like distant, repeating lightning strikes. Grandeur is small, roughly twice the mass of Earth's moon, but it endures in a place where space has been torn apart by stellar violence. Closer to familiar territory sits the TRAPPIST-1 system, a miniature clockwork of 7 rocky planets spinning tightly around a dim, cool star. 3 of these lie in the region where temperatures might allow liquid water to exist. If you imagine standing on one of these worlds, the star would look enormous in the sky. Much larger than the Sun appears from Earth, but far redder and cooler, glowing like a burning coal wrapped in velvet. The planets are so close to each other that at times another world might appear overhead, faintly visible as a curved disk. Here, the border between planet and neighbour becomes intimate, like islands spaced closely in a dark sea. Among all these extreme worlds, one more stands quietly, waiting with its own strange personality. GJ 1214b is what astronomers call a sub-Neptune, a planet larger than Earth but smaller than Neptune, wrapped in a thick atmosphere. Beneath that atmosphere might lie a vast ocean, not familiar water but of a high-pressure state, warm, dense, and layered. If clouds form there, they could rise in shimmering sheets, carrying droplets of materials that behave nothing like the ones we know. And because the atmosphere is thick and rich, the light filtering through it might turn the entire sky a deep, muted red or violet, as though the planet rests inside a room lit by a single simmering ember. All these worlds, bright, dark, fiery, icy, wandering, storm-racked, expand our idea of what a planet can be. They show us that Earth is only one version of possibility. The universe seems to keep a larger palette than we do, painting landscapes with molten minerals, glowing winds, rocky rain, and silent, lightless horizons. None of these places were designed to be habitable or gentle. They simply are what nature shaped them to be. And in their strangeness, they remind us that the laws of physics can create beauty in forms that defy intuition. As we drift away from these impossible-seeming worlds, the darkness ahead begins to glow with warmer colours again. Great clouds of gas and dust stretch across the void, illuminated from within by newborn stars. Ahead lie nebulae, cosmic structures so intricate and delicate that even photographs struggle to capture their quiet majesty. When we leave the strange worlds of distant planets behind, the darkness of space begins to brighten once more. Not with the firm light of stars, but with something softer, like drifting lanterns. These are nebulae, great clouds of gas and dust where stars are slowly assembled over spans of time so long that human history seems like a single breath beside them. From a distance, a nebula can look like a painted mural hung in the quiet of the cosmos. But if you let your imagination drift inward, you begin to see that these shapes are not decorations. They're places where gravity gathers scattered matter into dense knots, where new suns are kindled, where planets begin as grains of dust turning slowly in the glow. Among the most famous of these stellar nurseries lies the Eagle Nebula, home to the towering shapes called the Pillars of Creation. Each pillar stretches for 4 or 5 light years, though instead of thinking about measurements, imagine a formation so tall that if you travelled its length at the speed of a passing cloud, the journey would last longer than human civilization. These pillars are built from dense gas and dust sculpted by the light of nearby newborn stars. That light, far stronger than any daylight on Earth, pushes against the surface of the clouds, chipping away at their edges the way wind erodes cliffs. Over millions of years, the pillars become narrow spires, with small pockets inside where stars continue to gather, wrapped in protective cocoons of dust. If you drift closer in imagination, the colours deepen. The blues and golds are not painted, they are the result of different elements glowing when they are gently warmed by nearby starlight. Hydrogen, the simplest element, shines in soft red tones. Oxygen glows faintly green. Sulfur takes on rich orange hues. Together they create a palette that looks unreal to human eyes, because these colours appear in regions too faint to see without sensitive instruments. When telescopes amplify them, the nebula reveals itself like a slow-growing garden illuminated by invisible fire. Farther across the sky lies the Carina Nebula, a sprawling region that glows with an intensity almost unmatched. The newest images from large observatories reveal cliffs of gas that rise like mountain ranges, carved by winds from massive stars. In some places, jets of bright matter shoot outward from tiny forming stars, like fountains of light spraying into space. These jets travel at speeds far beyond anything familiar, yet they move silently, leaving glowing trails in the nebula's misty interior. If the pillars of creation feel like ancient stone cathedrals, the Carina Nebula feels like a canyon sculpted by warm winds, glowing with colours that shift like embers stirred by a gentle breeze. Closer to Earth lies a more modest nursery called Ophiuchi. It sits near the border of the constellations Scorpius and Ophiuchus, and is so close that it can be photographed in remarkable detail. Here, rather than towering spires, we find soft, braided clouds of dust lit by newborn stars tucked inside. The colours here are gentler, blues, faint yellows and quiet purples, like watercolour strokes drifting across a night sky. Because of its proximity, astronomers can watch stars in this region as they grow and gather mass. It is a reminder that star formation is not just a dramatic event happening in distant realms. It is a process occurring in our own cosmic neighbourhood. The Orion Nebula is another bright cradle of stars, visible even to the naked eye as a faint patch in the sword of the constellation Orion. But what appears as a faint smudge from Earth blossoms into a vast cavern of light when seen more closely. At its heart lies the Trapezium Cluster, a gathering of young, hot stars whose light illuminates the surrounding clouds. These stars are powerful enough to carve hollows in the gas, creating cavities and tunnels that extend for light years. If you imagined standing inside this cosmic cavern, Though no solid ground exists there, you would see walls of glowing gas rising on all sides, gently rippling under the influence of stellar winds. Not far from Orion lies the Horsehead Nebula, one of the most easily recognised shapes in the sky. Its silhouette resembles the profile of a horse, though the resemblance is purely the result of chance. The darker shape appears because the cloud in the foreground is thick enough to block the glowing gases behind it. What looks like a solid creature is in reality a delicate veil of dust, thinner than the finest mist on Earth. Light from behind it outlines the shape, giving it the appearance of a dark statue standing in front of a glowing curtain. Across all these nebulae, one theme remains constant. They are slow-growing gardens of starlight. Stars are not born in explosive moments, but in long, quiet gatherings of matter. Grains of dust drift together, pulled by gravity until they thicken into dense knots. As these knots grow, they warm, and when they reach a certain warmth, high enough for simple atoms to begin merging, they light up from within. That warm glow creates outward pressure, balancing gravity's inward pull. The star stabilizes, just as our sun did long ago, and begins the slow life cycle that may eventually give rise to planets, oceans, and perhaps even life. In these nurseries, light behaves in ways that seem impossible on Earth. It filters through thick clouds, scattering in violet ribbons. It reflects off the surfaces of dust grains, bending into shimmering arcs. In some regions, the gas is so thin that it would be far emptier than any vacuum humans could create. In others, it thickens just enough to allow structure and shadow. Everything here moves slowly, sculpted by time measured in hundreds of thousands of years. The stars flicker only in their infancy. Once they brighten, they burn steadily for ages. Nebulae remind us that the universe is not only built on extremes but also on patience. They show us the earliest chapters of stellar life, the moment before a star becomes a star, when light is only beginning to gather and shadows are soft. They are quiet, vast and tender, filled with the ancient ingredients from which all worlds eventually form. As we drift gently away from these glowing gardens, the light begins to thin again, and the colours fade into soft grey. Ahead lies a very different kind of beauty, the remnants of stars that have ended their lives in moments of brilliance and silence, leaving behind echoes that spread across the cosmos like ripples in a still pool. As the glowing gardens of starbirth fade behind us, the cosmos grows darker once more. But this darkness is not empty. It is filled with the quiet aftermath of celestial endings, places where stars lived long, steady lives and then, in a single moment of breathtaking brilliance, let go of everything they had gathered. These final gestures of dying stars are among the most spectacular phenomena in the universe, yet they unfold in silence. No sound escapes into space. There is only light, brief, powerful and unforgettable, followed by centuries of drifting echoes that spread outward like soft ripples on a cosmic pond. A supernova begins with a simple truth: even stars cannot burn forever. As they age, their inner furnaces struggle to hold balance. Gravity pulls inward, heat pushes outward. When the delicate equilibrium finally collapses, when a star can no longer support its own weight, it gives way in a sudden release of energy that outshines entire galaxies for a short moment. Instead of thinking of the physics as an explosion measured in unimaginable numbers, imagine a lantern suddenly flaring, bright enough to illuminate a whole landscape, then slowly dimming into embers. One of the most ancient and haunting remnants of such an event is the structure known as the Cygnus Loop, a wide arc of glowing gas formed by a supernova that occurred thousands of years ago. If you imagine a single stone dropping into a still lake and sending ripples through the water, you already understand the shape of the Cygnus loop. The star's final breath raced outward, sweeping up surrounding gas and shaping it into delicate filaments, long, wispy strands of glowing material stretched thin across hundreds of trillions of miles. These threads of colour look almost hand-painted, as if a brush dipped in lavender and silver had traced faint lines across the night. Not far from this region is the Veil Nebula, another shimmering remnant belonging to the same ancient explosion. The Veil Nebula glows in bright blues and reds, each colour a soft signature of the elements released by the star. Hydrogen shines in gentle crimson, oxygen in pale blue-green. When telescopes capture these colours, the nebula appears as a fluttering curtain, torn into thin ribbons that drift through space. The patterns are intricate and unpredictable, like silk blowing in a soft breeze, or like smoke swirling upward from an extinguished candle. Farther across the sky lies Cassiopeia A, one of the youngest and most studied supernova remnants in our galaxy. If you could drift toward it, you would see knots and arcs of glowing matter expanding outward, each tiny piece a fragment of a star that once shone brightly. Because the explosion happened only a few centuries ago in cosmic time, the debris is still moving visibly, inching outward year after year. Astronomers sometimes compare images taken years apart, revealing how these knots shift like slowly spreading petals. But instead of thinking of motion in terms of distance per second, imagine watching the growth of a tree from one season to the next, subtle enough to escape the naked eye, but steady and relentless when measured over long spans. One of the most striking examples of a stellar death echo is the red ribbon structure associated with SN 1006, a supernova recorded by ancient observers across several continents. They described it as a guest star, bright enough to cast shadows at night. Today, its remnants form thin arcs of glowing red that meander through the darkness like threads of fire caught in midair. When instruments detect these remnants, they reveal sheets of gas heated by the shockwave that continues to travel outward. The appearance is delicate, almost fragile, yet it marks the site of one of the most powerful events the Earth's sky has ever witnessed. Even more surreal is the phenomenon known as a light echo. The most famous example comes from V838 Monocerotis, a star that underwent a dramatic brightening in the early 2000s. Unlike a typical supernova, this event was more like a sudden flare, a burst of light that illuminated the surrounding dust. As the flash expanded outward, it lit up different layers of dust at different distances, creating the illusion of an expanding shell. But the dust itself wasn't moving, only the light was. Imagine standing in a quiet room and slowly turning up the brightness of a lantern. First, you see the walls near you, then the distant corners begin to glow. The light echoes across the surfaces, revealing shapes and textures that were hidden only moments before. In space, this effect becomes a silent symphony of illumination. When telescopes captured the light echo around V838 Monocerotis, the images revealed concentric layers, like ripples spreading across a cosmic pond. The dust was already there, arranged in uneven shells left behind by past motions. The flare simply revealed it, illuminating each layer like rings of fog touched by sunrise. When seen in time-lapse, the echo appeared to expand outward faster than light, not because anything moved that quickly, but because each layer of dust lit up in sequence as the moving wave of illumination reached it. Supernova remnants do more than create beauty, they reshape the galaxy. When a star dies, it releases the elements it forged during its lifetime. The carbon in our bodies, the oxygen in our breath, the iron in our blood, all were created in ancient stars that lived and died long before the sun was born. A supernova scatters these elements into the surrounding clouds, enriching them, preparing them for the next generation of stars and planets. The universe builds itself in cycles. Stars form, shine, collapse, and then seed the birth of new worlds. Instead of picturing this as a mechanical process, imagine a forest where fallen trees nourish the soil from which new saplings rise. The death of one life becomes the foundation of another. Shockwaves from supernovae can travel across space for thousands of years, sweeping up material like a slow-moving tide. These waves compress clouds of gas, sometimes triggering new star formation. In this way, the end of one star becomes the beginning of many others. The process is gentle when observed from afar, with no sudden noise or violent motion visible. Only the slow shifting of colour and shape hints at the forces at work. If you could drift within a supernova remnant, if such a journey were possible without harm, you would find the space thin and quiet. Despite the dramatic images captured by telescopes, these remnants are incredibly sparse. The gas filaments are so diffuse that they would feel like nothing at all if you passed through them. The glowing colours are illusions born of sensitive instruments, translating faint whispers of light into patterns we can see. These places are reminders of the impermanence of stars and the resilience of the cosmos. They show that even in endings there is grace, even in destruction there is creation. And in the silence that follows a star's final moment, the universe continues to shape itself, weaving the remnants into new beginnings. As we drift onward, the material grows denser again, and the quiet beauty of these echoes gives way to something more compact and more intense. Objects where matter is squeezed into forms so strange that they almost defy imagination. Ahead lie the densest stars the universe allows to exist, each one a reminder of how far the laws of nature can bend without breaking. As the fading echoes of supernovae slip into the distance behind us, the space ahead grows strangely taut, as though gravity itself is drawing breath. We are entering a region shaped not by clouds or gentle light, but by the most compact and intense objects the universe allows to exist without collapsing into oblivion. If nebulae are the soft gardens of starbirth, then neutron stars and their cousins, pulsars and magnetars, are the dense seeds left behind after stellar giants fall. Every one of these remnants is a lesson in how far matter can be compressed, how tightly physics can fold the ingredients of a star before something entirely different emerges. A neutron star begins its life in the final instant of a supernova. Once the outer layers of the star are thrown into space, the core collapses inward under its own weight. But instead of imagining the collapse as a complex equation, picture a great hall whose walls suddenly rush inward, squeezing everything toward the centre until only a small, dense sphere remains. That sphere, no larger than a city, contains more mass than the sun. Its density is beyond anything we encounter in daily life, so instead of trying to quantify it, imagine taking a mountain, an entire mountain, and pressing it down until it fits inside a spoon. That is the level of compression a neutron star embodies. Inside such an object, atoms are stripped of their familiar structure. Electrons and protons, normally separated by the gentle spaces that let matter hold shape, merge into new forms. What remains is matter packed so tightly that it is almost featureless. A teaspoon of this substance, if somehow removed, would weigh more than 1 billion tons on Earth. Rather than focusing on the numbers, think of it as weight beyond intuition. Matter folded tightly into a single breath, heavy enough to defy imagination. Despite their unimaginable density, neutron stars are dynamic places. Many spin rapidly, completing a full rotation in mere seconds or even less. These spinning remnants are called pulsars. The term comes not from a formula or a device, but from the pulses of light and radio waves that sweep across space like the beams of a lighthouse. If you imagine holding a flashlight and spinning in place, the beam would sweep across the wall around you. A pulsar behaves similarly, though it is gravity and magnetic fields, not hands and arms, that govern the motion. From afar, a pulsar's regular pulses appear as faint rhythmic flashes. Some pulse dozens of times each second, others pulse hundreds. Each flash represents a full rotation of the star. In a sense, pulsars are clocks so steady that some rival the precision of the best human-made instruments. But they are not mechanical. Their rhythm comes from the perfect balance of momentum and gravity, like a spinning dancer who continues moving long after the initial push. Even stranger than pulsars are magnetars, neutron stars with magnetic fields so powerful they can twist atoms and influence space around them. These fields are billions of times stronger than anything Earth's magnetism can produce. Instead of thinking of the strength in terms of units, imagine a force so intense that if a magnetar were as close to us as the moon, it could wipe the information stored on every magnetic device on Earth. Credit cards, hard drives, even small speakers. Thankfully, magnetars keep their distance. They're rare and often short-lived in their most intense states, gradually calming as they age. Magnetars can release bursts of energy known as starquakes. Brief jolts caused by shifts in their crusts, similar to earthquakes on Earth but vastly more powerful. When these quakes occur, the star's magnetic field can snap and rearrange itself, creating flashes of high-energy light. From afar, these bursts resemble distant sparks flickering across the darkness, brief messages from a dying star. But neutron stars do not exist in isolation. Sometimes two of them orbit each other, circling closer and closer in a slow dance shaped by their mutual gravity. This dance can last for millions of years, their orbits drifting inward so gently that no motion is visible on human timescales. But as they draw closer, something profound begins to happen. The space around them bends. Waves ripple through these fabric of space and time itself. These ripples, often referred to as gravitational waves, do not need formulas to be understood. Imagine dropping two pebbles into calm water and watching the circles expand outward. Now imagine the water is the universe itself, and the circles are waves of subtle distortion travelling outward through everything, silent, steady, and incredibly faint. When the two neutron stars finally merge, the collision releases a burst of light and heavy elements into space. This event is called a kilonova, though the name hardly captures its beauty. A kilonova glows with colours that shift from blue to red as the heated material expands and cools. The light lasts for days or weeks, far longer than the brief flare of a starquake or even many supernovae. But the most remarkable outcome is not the light. It is the creation of elements like gold, platinum, and rare heavy metals. The jewellery people wear, the metal used in spacecraft, and even the atoms found in the electronics may have been born in the heart of a kilonova billions of years ago. From a distance, the debris of such an explosion drifts outward in a glowing cloud. Each particle carries a history of unimaginable pressure and heat. Over millennia, these particles mix into the surrounding gas, becoming part of the raw material for new stars. In this way, neutron stars and their dramatic ends play a vital role in shaping the galaxy. Their deaths create the seeds that become future solar systems. If you could float near a neutron star, ignoring for a moment the impossibility of surviving its gravity and radiation, the object would appear deceptively small. Its surface might glow softly, its magnetic field would distort the space around it, and its spin would create a rhythm like a slow, steady drumbeat. But its true nature would remain hidden beneath its dense crust. These objects are reminders that the universe often hides its greatest extremes inside small packages. There is a quiet beauty in the way neutron stars embody both death and rebirth. They are the remains of stars that once shone brightly, yet they carry the potential to create new worlds. They bend space, twist magnetic fields, and generate waves that travel across the universe. And yet, despite their intensity, they sit silently in the dark, waiting for curious minds to find them. As we drift away from these dense rhythmic remnants, the darkness ahead seems to thicken. Light begins to warp, bending into shapes that challenge our understanding. We're approaching places where gravity becomes so strong that even light struggles to escape. Places where the fabric of the universe folds inward, creating shadows unlike any other. Ahead lie the black holes and quasars, the edges of reality itself. As we leave behind the dense hearts of dead stars, the darkness ahead becomes heavier, almost textured, as though the fabric of space was stretching into a deeper shade of night. In this region, light bends, time slows, and the ordinary rules that govern stars and planets begin to shift. Here lie the most extreme places allowed by the universe, black holes and the luminous objects they sometimes power, known as quasars and blazars. These are places where gravity presses inward with such intensity that not even light can slip away. Yet they coexist with some of the brightest phenomena in the cosmos, forming a contrast so stark that it feels almost like a dream woven from darkness and radiance. A black hole begins in the death of a massive star, though its birth is quieter than one might imagine. When such a star collapses, its core is squashed beyond the density of a neutron star. Instead of thinking in terms of equations or boundaries, imagine a valley so deep and steep that once something falls into it, there is simply no path back out. The walls of this valley grow infinitely steep near the centre, forming a place where escape becomes impossible. This invisible boundary is called the event horizon. Nothing can cross outward once it has crossed inward. Not light, not matter, not time as we understand it. Yet, despite their fearsome reputation, black holes are some of the quietest objects in the universe. They do not roar or devour in the way stories sometimes suggest. They simply exist, bending space and time around them like a heavy weight placed on a soft cloth. If you were to drift near a black hole from a safe distance, not close enough to cross the horizon, you would see light curve around it, forming arcs or even complete rings. These rings, called gravitational lensing, are like cosmic mirages, reflections of distant stars and galaxies bent into circular patterns by the black hole's gravity. Instead of imagining equations, picture looking into a dark mirror that reflects the universe itself, reshaped into elegant distortions. Two black holes have become especially famous in recent years. One sits in the heart of the galaxy M87, a colossal black hole many billions of times more massive than our Sun. The first image ever captured of a black hole showed this giant, a glowing ring of warm orange light circling a perfect darkness. That light is not the black hole itself, but the material orbiting it at tremendous speeds, heated to extreme temperatures as it spirals inward. The ring flickers and shifts like molten metal stirred in a vast cosmic cauldron. Closer to home lies Sagittarius A, the supermassive black hole at the centre of our Milky Way. Though smaller than the one in M87, it is still enormous, millions of times more massive than the Sun. From our vantage point on Earth, it appears hidden behind thick clouds of dust, but radio telescopes have revealed its shape. Its glowing ring is softer, more delicate, like a lantern wrapped in thin cloth. Despite its power, Sagittarius A rests quietly in the centre of our galaxy, stirring stars into slow orbits around it. Even more astounding are the true giants of the black hole world, behemoths like Ton 618 and Phoenix A. These are among the most massive black holes known, weighing billions upon billions of suns. Instead of focusing on impossible numbers, imagine a heart so immense that it anchors an entire galaxy with its presence. These black holes sit at the cores of ancient galaxies, shaping everything from the movement of stars to the glow of cosmic dust. Around some of the most active black holes form structures of breathtaking beauty and power. When matter spirals inward, it does not fall straight down. Instead, it forms a disk of swirling gas, an accretion disk, heated by friction into glowing bands of yellow, orange and blue. These disks spin at incredible speeds, releasing torrents of energy. Their edges can ripple with waves of brightness, almost like shimmering silk stretched around a spinning lantern. Sometimes, in the most energetic systems, jets of material shoot outward from the poles of the black hole. These jets travel at speeds approaching the speed of light, extending for thousands or even millions of light years. They're bright enough to outshine entire galaxies, burning like narrow torches pointed into the void. When the jet of a black hole is aimed almost directly at Earth, the object becomes what astronomers call a blazar. But instead of thinking about technical distinctions, imagine simply a cosmic lighthouse beam pointed in our direction, a narrow, powerful ray of light stretching across unimaginable distances. Farther away in time and space lie quasars, the luminous hearts of young galaxies. A quasar shines when a supermassive black hole is actively consuming gas and dust, causing the accretion disk to flare with intense brightness. Quasars can outshine every star in their host galaxy combined. They're so bright that we can see them across billions of light years, glimpsing the early universe through their glow. Their light has travelled so long and far that what we see now is a moment from ancient cosmic history, preserved in amber. The gravity around black holes bends space so dramatically that light from background galaxies can sometimes be curved into nearly perfect circles called Einstein rings. These circles look like delicate halos floating in space, a strange sight, as if the universe were looking at itself in a distorted mirror. They remind us that light is not a rigid arrow, but a flexible thread that can be shaped by the curves of space-time. Beyond the confirmed realities of black holes lie the more speculative ideas, one of the most intriguing being wormholes. A wormhole, if such a thing could exist, would be like a tunnel linking two distant regions of space. Instead of treating the concept as a set of complicated equations, imagine folding a sheet of paper so that two far apart points touch. A wormhole is the hypothetical bridge between those points. From the outside, it might resemble a shimmering sphere reflecting the distant sky in unusual patterns. We do not know whether these structures exist in nature, but the idea itself offers a gentle reminder of how flexible the universe might be. Despite their strangeness, black holes are not the villains of the cosmos. They are simply the natural consequence of gravity pushing matter to its limit. They serve as anchors in galaxies, engines for brilliant quasars, and sculptors of cosmic structure. Their extremes illuminate the rules that govern all stars and all light, and for all their power, they remain silent. No sound escapes from within, no dramatic noise accompanies their motions. They are places defined not by violence, but by the quiet persistence of gravity. As we drift onward from these shadowed giants, the darkness begins to fill once more with gentle lights, stars arranged in spirals, clusters and streams. Ahead lie the galaxies, the vast cities of illumination scattered across the night. As we drift away from the deep shadows cast by black holes and quasars, the darkness begins to brighten once more, not with the glow of a single star, but with the soft shimmer of countless stars gathered into vast cities of light. Galaxies are the grand architecture of the universe, sprawling collections of stars, dust and gas arranged in shapes so graceful that they often look like celestial artwork suspended in the void. Each one is its own world of worlds, a cosmic metropolis where suns gather in clusters and spiral arms, where dust lanes run like rivers, and where light travels for tens of thousands of years before reaching the edge. Our own home, the Milky Way, is one such city of light. Though we cannot step outside it to see its full form, our observations suggest it is a barred spiral galaxy, shaped like a spinning pinwheel with a glowing bar running through its centre. Its arms, graceful arcs of stars, gas and dust, wind outward like curling brushstrokes. Within these arms lie regions dense with nebulae, clusters, and young stars still wrapped in swaddle of dust. If you were able to drift near the edge of one of the arms, you would see stars scattered like lanterns along a twisting path, each one glowing softly in the vast darkness. Far beyond the Milky Way lies our closest large neighbour, the Andromeda Galaxy. It is enormous, holding perhaps 1 trillion stars, more than all the grains of sand on many beaches combined. But instead of focusing on the magnitude, imagine a swirling storm of light, wider than any structure we could meaningfully picture, slowly turning in the dark. Andromeda appears to be gliding toward the Milky Way in a dance that will take billions of years to complete. One day, long after humanity has passed its current chapter, the two galaxies will merge into a single, larger structure. The stars themselves are unlikely to collide. Space between them is too vast, but the shapes of the galaxies will stretch, twist, and blend, forming new spirals or perhaps an entirely new kind of structure. Some galaxies stand out because of their unusual features. The Sombrero Galaxy, for example, carries a sharp, dark band of dust around its luminous central bulge. This dust lane gives it the appearance of a broad-brimmed hat, floating quietly in the darkness. Its central bulge glows brightly, illuminated by countless older stars packed tightly together. If the Milky Way's bar is a slender beam of light, the Sombrero Galaxy's bulge is a glowing lantern surrounded by a soft, shadowy ring. The Whirlpool Galaxy offers a different kind of beauty. It is a grand design spiral, meaning its spiral arms are clearly defined and proportioned, curling almost symmetrically around the centre. What makes the Whirlpool even more striking is that it interacts with a smaller companion galaxy. This companion tugs at the Whirlpool's arms with gravitational fingers, stretching them out and sparking waves of new star formation. If you imagine two dancers moving around each other in a slow, binding rhythm, the interaction between these galaxies resembles that kind of cosmic waltz. Another impressive system is Messier 82, sometimes called the Cigar Galaxy. It is a starburst galaxy, a place where stars are being born at a furious pace. Winds driven by newborn stars push dust and gas out of the galaxy's core, creating bright plumes that glow with a rosy hue. These plumes are not flames but illuminated dust carried along by powerful outflows. Observing Messier 82 is like watching a city undergoing constant construction. New stars lighting up, clusters forming, and dust swirling outward in glowing fountains. The Black Eye Galaxy, named for its striking appearance, features a dark ring of dust cutting across its bright centre. This ring gives the illusion of an eye outlined in shadow. The galaxy's internal dynamics are even stranger. Some of its gas rotates in the opposite direction from its stars, suggesting that it once absorbed a smaller galaxy. Instead of imagining complex orbital mechanics, picture a gently spinning cloud absorbing a smaller swirl of dust. The different spins combine, creating patterns like overlapping ripples in a pond. Then there is the Pleiades, a cluster rather than a full galaxy, but one that holds a special place in the night sky. The Pleiades are a group of young, hot stars wrapped in a delicate blue glow. This glow is caused by tiny dust grains reflecting their starlight, giving the cluster a soft, ethereal appearance. To the naked eye, the Pleiades appear as a small grouping of stars, sometimes called the Seven Sisters, but through a telescope the cluster blossoms into a shimmering cloud. Each star seems to float inside a faint blue mist, as if wrapped in a veil of stardust. The shapes of galaxies reflect the forces that sculpt them. Spiral galaxies such as the Milky Way and Andromeda owe their structure to rotation and the distribution of mass within them. Their arms form where waves of compressed gas sweep through, creating bursts of star formation. Elliptical galaxies, on the other hand, are smoother and more uniform, shaped more like spheres or elongated ovals. They form when galaxies merge or collide, mixing their stars into a more even, featureless shape. These elliptical galaxies often contain older stars and less gas, giving them a dim reddish tint instead of the bright blues seen in young star-forming spirals. Then there are peculiar galaxies, systems so odd that they defy simple classification. Some stretch into long tails after pulling on each other in past encounters. Others appear distorted or asymmetrical, shaped by collisions or by the gravitational influence of nearby neighbours. These strange forms are reminders that galaxies are not static paintings, but living structures that evolve over billions of years. They shift, stretch, merge, and dissolve, creating new patterns as they move. If you were to drift within a galaxy, you would find that its beauty is made not from dense matter, but from emptiness. Even in regions that glow with thousands of stars, the space between those stars is vast. You could travel light years without brushing against anything solid, and yet the combined glow of these distant suns forms the soft light that defines a galaxy's shape. From afar, galaxies appear as unified objects, but up close they are delicate assemblies of countless small lights. Galaxies are the universe's great tapestries, woven from stars, dust, and dark matter, arranged in shapes determined by time and gravity. Some glow brightly with new stars, others rest quietly with older ones. Some twist into spirals, others settle into ovals, and some defy symmetry altogether. As we drift onward from these immense cities of light, the stars begin to cluster even more densely. Gravity gathers galaxies into groups, groups into clusters, and clusters into superclusters, creating structures so large that they can only be sensed as patterns across the sky. Ahead lies a region where galaxies interact like continents sliding across a cosmic ocean, shaping vast tidal currents of light. As we drift beyond the graceful shapes of individual galaxies, a deeper pattern begins to emerge, one woven not from stars alone, but from the collective pull of gravity over enormous distances. Galaxies rarely travel alone. Instead, they gather in families ranging from tight groups to massive clusters, each one containing dozens, hundreds, or even thousands of galaxies. These gatherings move slowly through the cosmos like drifting islands carried by ancient tides. The spaces between them are dark, but the relationships they form are rich and dynamic, shaped by collisions, interactions, and the subtle tug of dark matter. In this region, gravity becomes an artist, painting broad strokes across the sky. One of the most stunning examples of this artistry is Omega Centauri. At first glance, it looks like a shimmering sphere of countless stars tightly packed into a glowing ball. But describing it as a cluster almost feels too simple. Omega Centauri may actually be the remnant of a small galaxy that the Milky Way absorbed long ago. Today it holds roughly 10 million stars, far more than a typical star cluster, and they glitter so closely together that, if you were inside it, the night sky would glow with hundreds of bright stars in every direction. Instead of imagining the distance between stars as vast emptiness, picture a landscape where light seems to pool in the air, where darkness never truly settles. Farther out lies the Large Magellanic Cloud, one of the Milky Way's companion galaxies. It is a dwarf galaxy filled with gas, dust, and regions of intense star formation. Within it lies the Tarantula Nebula, a region so bright that if it were as close to Earth as the Orion Nebula, its glow would cast shadows at night. The Tarantula Nebula is a place where newborn stars gather in enormous clusters, their combined light carving radiant hollows into the surrounding gas. Streams of material flow outward from the heat and motion, forming shapes that shift slowly over centuries. The Large Magellanic Cloud itself orbits the Milky Way like a companion lantern, carrying its own delicate ecosystems of star birth and evolution. Some galaxy groups are far tighter, bound so closely that their members distort one another's shapes. The Hickson Compact Group series contains many of these intimate arrangements, but one of the most striking is Hickson Compact Group 92, often called Stephan's Quintet. This group consists of several galaxies in close proximity, interacting in a gravitational dance. Their mutual attraction pulls long tendrils of stars outward, forming tidal tails that stretch like luminous streams. If you imagine swirling ink spreading slowly through water, you have a sense of how these galaxies draw out one another's material. The interactions spark bursts of star formation, lighting up new regions with clusters of fresh, bright stars. Far more massive than compact groups are galaxy clusters, vast structures where hundreds or thousands of galaxies gather. One of the most unusual is the Pandora cluster, a structure formed from the collision and merging of several smaller clusters. Its appearance is so complex that astronomers once mistook it for a simple system. But deeper observations revealed layers of galaxies and dark matter overlapping like multiple brushstrokes on a single canvas. Dark matter, though invisible, shapes the paths of galaxies within the cluster. Instead of thinking of dark matter as a substance you can touch, imagine it as a faint scaffolding, a hidden framework that guides where light and matter can go. The Pandora cluster's gravity is strong enough to bend light itself, creating magnified images of distant galaxies behind it. This bending produces arcs and stretched shapes, as though the universe was seen through a glass lens. In these distorted windows, astronomers find some of the earliest galaxies ever formed. Without the natural magnification of clusters like Pandora, these ancient lights would be too faint to detect. Gravity becomes not only a force but an instrument, a lens crafted by the cosmos to reveal its own history. On the opposite end of the spectrum lies IC 1101, one of the largest galaxies ever observed. It sits at the core of the Abell 2229 galaxy cluster and stretches several million light-years across. Instead of contemplating its size in numerical terms, imagine a city of light so vast that its outskirts would take longer to traverse than the entire Milky Way. IC 1101 shines softly, its diffuse halo filled with older stars. Around it, smaller galaxies orbit like distant satellites, pulled into slow spirals by its immense gravitational influence. These motions have shaped IC 1101 into a supergiant, its body swollen by countless mergers over billions of years. Galaxy clusters are not still landscapes. They are dynamic environments where galaxies drift, collide, and reshape each other over vast stretches of time. When two galaxies meet, they rarely crash head-on. Instead, their stars pass through one another like swarms of fireflies merging and parting. The real collisions occur between clouds of gas. When these clouds slam together, they compress and heat, creating waves of pressure that trigger bursts of new stars. These events unfold without sound, but the motion alone is dramatic. A slow, swirling reshaping of entire galactic neighborhoods. In some clusters, galaxies move so quickly that their gas tails stream behind them, forming long, ghostly trails. These trails are created as galaxies plow through hot plasma that fills the spaces between cluster members. Imagine a boat cutting through water and leaving ripples behind. Now, imagine a galaxy cutting through invisible ocean currents of heated gas, leaving long, drifting shapes behind it. These shapes are faint, but when illuminated by the right instruments, they reveal the quiet turbulence inside the cluster. The forces shaping clusters extend far beyond the galaxies themselves. Dark matter, hovering invisibly, holds these vast structures together. Though we cannot see it, we can observe its effects in the motions of galaxies and in the bending of light. Instead of trying to quantify it, imagine a gentle, unseen current running beneath the surface of a vast lake, guiding the motion of everything above. Clusters are the universe's grand gatherings. They show how galaxies, despite their independence, are bound by a larger architecture. They drift together, collide, merge, and evolve. They form patterns that stretch across millions of light years, creating cosmic continents that slowly shift over cosmic ages. As we drift beyond these titanic structures, the galaxies begin to thin out once more. Their light becomes sparse, separated by enormous stretches of darkness. Ahead lies the largest pattern of all, the cosmic web, a structure so vast that it can only be sensed through the faintest threads of light and the gentlest pull of gravity. As we drift beyond the richly populated realms of galaxy clusters, the cosmos opens into something far more delicate and far more immense. The light begins to thin, not because we are approaching emptiness, but because the universe is arranged in a pattern so large that human senses cannot hold it all at once. This pattern is known as the cosmic web. It is the grand design of matter on the larger scales, a network of filaments, knots, and hollows stretching across hundreds of millions of light years. Rather than imagining a diagram or a grid, picture a vast lace of faint threads glowing in the dark, connecting clusters of galaxies like beads on an interstellar necklace. The cosmic web is shaped by the quiet pull of gravity and by the presence of something invisible, dark matter. Dark matter does not shine, scatter light, or reveal itself directly to our senses. Instead of picturing it as a substance, imagine it as the hidden framework of a building, the bones of a great cathedral behind its stained glass. We cannot see the framework itself, but the glass, the visible galaxies, rests upon it, held in place by its quiet strength. Filaments in the cosmic web are enormous strands of galaxies, sometimes stretching for hundreds of millions of light years. Yet the matter within them is incredibly sparse. A single cubic mile of one of these filaments might contain only a few stray particles, but over immense distances these sparse particles add up, flowing along unseen currents of dark matter. If you could drift inside one of these filaments, you would find yourself surrounded by a ghostly landscape, galaxies glowing faintly like distant campfires, scattered along a path too long and too faint to measure. Between these filaments lie vast expanses of almost nothing, the cosmic voids. One of the most curious of these is called the KBC void, a region of space with fewer galaxies than expected. Instead of numbers or measurements, imagine a valley in a mountain range, but stretched across hundreds of millions of light years. In this valley, the air is thin, the lights are sparse, and the silence feels deeper than any quiet we can imagine. The KBC void is not fully empty. It contains galaxies and dark matter, but in far lower density than surrounding regions. These voids influence how light travels and how galaxies move, creating gentle distortions that help astronomers piece together the cosmic web like detectives reconstructing a tapestry from scattered threads. At the intersections of filaments lie massive nodes, galaxy clusters like the ones we've just visited. If the filaments are the roads of the cosmic web, these clusters are its cities. They anchor the structure, pulling in surrounding matter through their immense gravitational presence. Over billions of years, these nodes grow, merging and reshaping themselves. The web evolves slowly, almost imperceptibly, like frost forming delicate patterns across a window pane on a cold night. The reason the web forms at all lies in the interplay between gravity, dark matter, and the expansion of the universe. Gravity tries to draw matter together, while dark energy, the mysterious force causing the cosmos to expand faster and faster, pushes everything farther apart. Dark energy does not behave like wind or pressure. Instead, imagine it as a soft outward breath filling the space between galaxies. It gently stretches the fabric of the cosmos, making distant galaxies drift away from each other. This outward breathing becomes more noticeable as we look farther into the past. Light from remote galaxies arrives stretched and softened, a phenomenon called redshifting. But instead of thinking of wavelengths and numbers, imagine a musical note played in a vast hall, slowly lowering in tone as it travels through quiet air. Dark energy shapes the large-scale structure of the universe, influencing where filaments form and how they stretch. Gravity creates the threads. Dark energy pulls the threads apart. The result is the cosmic web, a pattern both fragile and immense, woven over billions of years. Within this web lie features that seem almost like fingerprints of the early universe. One of these is the cosmic microwave background, the faint afterglow of the universe's birth. When we observe this ancient light, we notice tiny temperature variations, small warm spots and cold spots across the sky. The cold spots are subtle, like faint shadows cast by ripples on a pond. Some of these appear unusually large, creating puzzles that astronomers continue to study. These faint cold patches may hint at supervoids or other large-scale structures, though their full meaning remains elusive. They are whispers from a time when the universe was only a few 100,000 years old, a time long before the first stars ignited. If we could drift through the cosmic web without concern for distance or time, we would see patterns formed from the simplest materials, hydrogen, helium, and dark matter, shaped by forces that act quietly but persistently. Filaments would rise around us like misty highways, faint to the point of near invisibility. The web would extend in every direction, a reminder that the universe is structured not by human design but by the natural tendencies of matter to gather, stretch, and settle. Despite its scale, the cosmic web is not static. It grows, shifts, and thins as the universe expands. Gravity pulls matter into denser knots, while dark energy stretches the gaps between them. Over immense timescales, the filaments may become thinner and the voids wider as the outward breath of expansion continues. One day, distant galaxies may drift so far apart that many will fade from view entirely, their light too stretched to reach us. The night sky will grow quieter, but the cosmic web will still exist, a silent structure holding the universe together. Drifting through these vast patterns feels almost like wandering through the mind of the cosmos itself, seeing how it organizes, how it flows, and how it breathes. The cosmic web reminds us that even the emptiest regions of space hold quiet beauty. It shows us that the universe is not random chaos, but an intricate design shaped by forces that act slowly and gently on unimaginable scales. And as we leave the delicate threads behind us, drifting back toward a more familiar corner of the cosmos, we are reminded that all these grand structures, from neutron stars to black holes to galaxy clusters, make Earth's gentle stability feel even more remarkable. Ahead, our journey returns to the small blue world where life found its balance, a place shaped by ordinary sunlight, flowing oceans, and a quiet companionship with a single moon. After journeying through the deepest structures of the universe, after drifting past suns born in glowing caverns, listening to the silent echoes of dying stars, brushing along the edges of black holes, and tracing the delicate threads of the cosmic web, returning to Earth feels like sinking gently into warm water after a long, cold night. Compared to the violent, spectacular, and often surreal landscapes scattered across the cosmos, our homeworld seems almost impossibly calm. And yet, this calm is not an accident. It is the result of a long chain of cosmic chances, quiet balances, and gentle protections that have allowed life to take root here in ways that appear, at least from our vantage point, unique. The first gift Earth received is its star. The Sun is neither too small nor too large. It is steady, predictable, and stable, qualities that are surprisingly rare among stars. Instead of pulsing violently or erupting constantly, the Sun burns with a controlled warmth, like a hearth that has been tended with care. Its energy output changes only slightly over long periods, allowing Earth to maintain a climate mild enough for oceans to form and endure. If the Sun were just a little hotter or a little more erratic, the story of life on Earth would never have unfolded. Next is the orbit Earth follows. It is nearly circular, which keeps the planet at a consistent distance from the Sun. This gentle predictability, neither too close nor too far, creates a temperature range where water can remain liquid for most of the planet's history. Instead of imagining complicated orbital diagrams, picture Earth as a small boat gliding around a warm lantern, always at just the right distance to stay comfortable without drifting into heat or darkness. Many exoplanets we've visited in imagination today orbit dangerously close to their stars, scorched by unending daylight, while others are locked in deep, permanent night. Earth's orbit sits comfortably between these extremes. Then there is the Moon, an unusually large companion compared to the size of its host planet. The Moon stabilizes Earth's tilt, preventing it from wobbling dramatically. Without this stabilizing influence, Earth's seasons might swing wildly, turning ice fields into tropical forests and back again over short geological periods. Instead, the Moon holds Earth's tilt steady, creating a slow, consistent cycle of seasons that living things have adapted to over millions of years. The Moon also stirs the oceans with its tide, mixing nutrients, guiding early life, and setting the rhythm for coastal ecosystems. Earth's magnetic field is another quiet guardian. Generated by the swirling motion of molten metal deep within the planet, this invisible shield deflects charged particles streaming from the Sun. Without it, Earth's atmosphere might have been stripped away long ago like Mars's was. But with the shield in place, harmful solar particles are guided harmlessly toward the poles, where they paint the sky with auroras, those shimmering curtains of green and violet light that ripple across night skies near the Arctic and Antarctic. Beneath Earth's surface lies another piece of its stability: tectonic plates. These vast slabs of crust shift slowly over time, recycling carbon, shaping continents, and releasing minerals into oceans. Though earthquakes and volcanoes can be destructive on small scales, the long-term influence of plate tectonics helps regulate Earth's climate. Carbon is locked away in rocks and released through volcanic vents, maintaining a balance that keeps the atmosphere from drifting into extremes. Many planets, including Mars and Venus, lack this slow geological breathing. On Venus, the lack of plate tectonics likely contributed to a runaway greenhouse effect trapping heat beneath bloated clouds. On Mars, geological stillness meant that its early warm atmosphere eventually thinned into cold emptiness. Earth's chemistry is another part of this gentle balance. The planet formed with abundant water, carbon, silicon, and a rich mix of other elements forged in ancient supernovae and kilonovae. The iron in our blood, the calcium in our bones, the oxygen we breathe, all were born in the deaths of massive stars. In that sense, Earth is a child of cosmic violence that somehow found its way into tranquility. Instead of imagining formulas for element formation, picture the universe as a garden where old stars fall like blossoms, enriching the soil from which new seeds emerge. Earth's atmosphere is thin and fragile, yet just right for life. Its mix of gases creates a protective blanket that holds warmth, filters harmful radiation, and allows sunlight to reach the surface in a gentle spectrum ideal for photosynthesis. Plants and microbes have shaped this atmosphere over billions of years, turning harsh early conditions into the breathable air we now depend on. It is a partnership, a slow, symbiotic relationship between geology, biology, and sunlight. Even Earth's position in the Milky Way plays a role. We reside in a quiet suburb of the galaxy, far from the bustling energetic core where radiation storms and gravitational disruptions are more common. Our location in one of the spiral arms, at a safe distance from deadly supernovae, gives Earth a rare shield from catastrophic cosmic events. Many worlds may form closer to galactic centres, where intense radiation makes life difficult or impossible. Here, in a calmer region, Earth has been allowed to evolve undisturbed for billions of years. All of these factors, our star, our orbit, our moon, our magnetic shield, our moving crust, our rich chemistry, and our place in the galaxy, combine to create what feels like a quiet oasis in a universe filled with extremes. While we were travelling through shimmering nebulae, collapsing neutron stars and blazing quasars, the contrast grew clearer. Most of the cosmos operates at levels of intensity that human bodies and minds were never meant to witness up close. Earth, by comparison, is gentle. Its storms roar, but they do not tear the planet apart. Its seasons shift, but they do not devour entire continents. Its oceans churn, but they offer cradle and nourishment as often as they offer danger. Standing on Earth's surface, on sand, soil, or stone, you feel none of the cosmic violence from which the planet was shaped. You hear the rustle of leaves, the hush of wind, the rhythm of waves. You feel gravity pull gently downward, not with crushing force, but with familiar steadiness. The sunlight warms your skin without searing it. The air fills your lungs without effort. When seen against the backdrop of the universe we just explored, Earth becomes something profoundly precious. A quiet harbour in a sea of storms, a blue world wrapped in protective layers, rich with life, steady in its rhythms, and calm enough to nurture consciousness, something exceedingly rare in a cosmos dominated by extremes. Perhaps that is the most humbling part of this journey. For all the grand wonders we've visited, towering nebulae, luminous galaxies, spiraling clusters, and the cosmic web itself, the rarest marvel may be the one beneath our feet. A place where complexity grows, where life endures, and where minds can look upward and wonder. As we settle gently back onto this small blue sphere, the universe stretches overhead in quiet brilliance. The stars we visited glow faintly in the distance. The galaxies drift like lanterns across the night, and Earth, turning slowly beneath them, continues its patient orbit, calm, steady, and astonishingly alive.